Hi, this is Ron Johnson with Intersil Corporation, here to give you a brief overview of our new web application for PowerCompass. If you're familiar with PowerCompass, we first released with an Excel tool, but this is the new web app version. So as you can see on the screen here, here's the starting point for the PowerCompass web application. If you're not familiar with this, you can go to our website, and under the Tools section you can find the PowerCompass tool, and that'll bring you to the application. So as the start of this tool here, you'll see there is a start a new project or use project template. Start a new project will basically give you a kind of a blank slate to create your input rails and your output requirements as you need. You can also use a project template, which we now support over 250 project templates. We have FPGA vendors like Altera, Xilinx, Lattice, and Actel in the list here, and you can pull up one of those and jumpstart your project there by the basic requirements for a given FPGA will be loaded into the system. Just to give an example of that, I'm going to go ahead and start the tool in a project. So I'm going to go ahead and click over here, and I will pick something. I'm just going to pick a example template. So under other, there's an example template. I'm going to continue, and that loads in that requirements of that template. As you can see, there's a system rail set up over here. You have your VN min and max 12 volts. You could also have a range in here. How much current that input supply is capable of. And we also have the available rail power, and you're probably wondering where that comes from. What we do is we use an assumed minimum efficiency, and we deduct the power requirements of all the outputs that are assigned to that rail. And what that does is it gives you a kind of a power budget of how much power is left on the input rail. And like I say, that's using this assumed 85% efficiency, which you can adjust to your desire. That's just a good starting point. You can add as many input system rails as you would like. They'll just add on down, and you can have multiple ones. As far as outputs, you can add as many outputs as you would like. Basically what you do is you connect the source rail either to a system input rail or to another output of another device. So like in this case here, down here, we see LDO supply, and we see this little arrow down means that it's feeding some secondary supplies. So LDO supply is the source for these two outputs here that are coming out here. So that's how that's indicated on the web application. So yeah, just to go over, this first rail here, we have 1.5 volts set up at 19.6 amps. Sequencing is available, so we do the up sequencing. You can enter your requirements for your up sequencing, and the down sequencing is always an inverse of the up sequencing that you define. So once you have everything laid out, then you could go to the next point, which would be find solutions. There is one other option in this screen, and right now the order and the layout of these rails is based on how they were loaded in on the template or how the customer or yourself entered the data. There is an option here to optimize, and what that will do is it'll look at all the rails, their sequencing requirements, their input source rails, and it will see if any of them can be collapsed down to make less individual output requirements. So as an example, these two LDO supplies, they're both being sourced from the same input supply. They both have the same output voltage. They have the same sequence. One is a 1.1 amp and one is 160 milliamps. So in theory, these two output requirements could be collapsed into one, summing the current requirements. If you don't want to do something like that, then you would leave it as user defined. But if you would like to try to optimize your system once you create it, you could click the optimized, and what you'll see is what it did is it collapsed these two rails down and made one one VCO, comma VCO2, and it summed the currents there. So looking over your output requirements, if there's any special requirements such as something needs to have synchronization input or synchronization output, LDO requirements, or any part needs to have a power good or enable pins, anything like that that's a special requirement for that rail, you can turn on in the more options. Just to show you, these last supply down here is required to be an LDO. So in that case, we've turned on that option for that rail to define it as being an LDO. So it won't show any other options for that in the results. It will only show LDO options. So once you have this all done, the next step will be to look at suggested parts by the tool, and we'll do that here in just a second.